and I hope this is gonna work. And the only notes I'm gonna do is this one. I was really trying to emphasize that 35 in the other class, because sometimes they don't listen. Anyway, let's move that over here. Let's go to my actual BC, and then I wonder, oh, we got a doozy. You want to get nuts? Let's get nuts. Okay, so I did kind of go through this pretty quick with the other hour, and I guess I could use this blank set of notes. I don't know what I did last year because these were both blank. So anyway, and then without my headphones because you know what happened. Um, this microphone's not great, so anytime I turn my head, the sound isn't great. But that's what I'm doing from there. I'm not plugging those. Well, they're broke, but so maybe I gotta go like this because I do have to keep looking at the screen here. All right, set up an appropriate equation to answer your question. Solve each equation. You could use graph intersections to check answers. We're going to hit this graphically here. But the first thing you could do without a graphing calculator is this. Trying to get the pen activated. All right, so I see this. H of t equals 4 cosine pi over 6t, where the height of the water in feet, time in hours, corresponds to 12 p.m. noon. All right, good. So what is the water's level at high tide? You should actually be able to answer this question before you even go into your calculator. And the answer is, anyone know? Anyone know? I think I heard someone say it. Not 6, but what? 7. All right, because this could at most turn into 1. You know that the high value for cosine. I had the same problem talking first hour too. That's why it was really bad notes. But the highest value could be 1. The lowest value could be -1. That's the range for cosine, right? Right. So what's the low tide? What's the low tide then if that yellow is -1? No, it'd be what? What's 4 plus 3 times -1? 1. So high tide to low tide is, 7 to 1. Okay? At what time does this occur for 0 to 24? That's 24 hours. That's going to happen twice. So, what is the water level at high tide? Oh, and by the way, when you plug in 0 for t, 0 times pi over 6 is 0. Cosine of 0 is what? What's cosine of 0? I'm holding my arm out to the left. No. 1. Cosine of 0 is 1. You okay over there? You got enough oxygen? Big yawn. All right. So it happens at the starts. And then it happens at the start 7 to 1. I feel like, you know what? Oh my gosh. This was am I doing the right notes? I feel like I'm in the wrong notes here. This is funny. This was on AB's homework today. That's why I'm being thrown off here. All right, and then this happens at 12 hours. And then why did I know that? I think I'm thinking about what I did with the other class. Oh, I'm a maroon. I didn't find the period, and I did know that. 2 pi over 6 equals 12. That's why I knew it was at 12. I knew I already calculated that in my brain, but I forgot with my brain being fractured right now. So then from 12 to 24, we get another interaction of this. Doink. All right. So the tide happens every 12 hours, a full cycle. Then it happens again. All right. Kind of weird. I thought something different there, but in reality, really bad graph there. So what is the water level at high tide? At what times does that happen? Well, it looks like at 0 hours, 12 hours, and 24 hours, right? Okay, so now that we have that picture. Give all the times on the interval where the water level is 2 feet high. Then this is where my video became a disaster because I wasn't able. That's the wrong thing. That's because these are both white boxes here. Go ahead, get your graphing calculator if you want to play along here. I don't know if we've gone through this before. Oh, you probably can't hear me because I've turned to the back side of the computer away from the microphone. Now I'm by the screen in class, so I'm trying to move my uh, computer as such. Let me use the mouse for this. It's funny, yeah, that's why I'm kind of like not confused, but we're almost like overlapping AB class right now. So this is AB notes. So y equals clear. Yeah, that's a different equation. So now I'll go to the calculator up here. Clear. Get rid of that 40. Clear. Just remind yourself. There are a couple things. Again, is it 4? 4 plus, right? 4 plus 3? I got the 4 covered. And then cosine. And then you can do pi over 6. This is what I was not allowed to do first hour. So that's why that video, I crushed it. Killed it. I'm just going to do times x just to, hey, get that away from the angle measure. You don't really need that times. But I guess that's it. Okay, you know what I could do? I could actually check myself here. You know what? Yeah, that's good. 0 to 24. I just go a little bit less, -1. And then actually this is not good. I only go from 1 to 7. So 0 to 10. And then take a look at this graph. Now, if you don't get this, here's why. Number 1, your mode. You have to be in radians. So someone in AB actually made a point when he was trying to follow along the flip math video. Hey, my graph is way off. This is why. Hey, let's change it to degrees and show you how bad this graph looks. It's because 1 radian is not the same as 1 degree. Boom. You know why that looks like that? That's the beginning of the high point of cosine, but these are only 10 degrees. That is not the same as 10 radians. 10 degrees is a very small angle measure, right? So you have to understand why that occurred. Well, not really. You have to understand that you have to be in radians in order to get these graphs to look appropriate. All right, and then that's good to go. So blah 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 blah. And then what does it say? Give all the times where the water level is 2 feet high. Okay, so I can go back to my graph and calculator. I think there we go. And then that's when we go to. The height is the h of t. So that's when we plug in 2 here, and then we find those intersections. Isn't that easy, right? Now just do one intersection for giggles. Second, calc, 5. And then if I wanted to find any one of these, I just go close to it and press enter 3 times till you see the word intersection. So what is this in hours? So 7.6 hours after 12 noon. So I guess that's like a 7 something, right? Maybe 7 o'clock, and then 7.6 times or an hour or 60 minutes. You can get the actual time there. All right, and then you can find the other. You don't need me for the other ones, right? You okay? Everything fine? All right, because we got to get to the tough stuff. Right, and then this one, airplane is asked to stay in a holding pattern, airport, blah, 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 represents the D in miles of the airplane from the airport at time X in minutes. When the plane enters the holding pattern, X equals 0, how far is it from O'Hare? We could actually do that without a calculator. 0 times 0.65 is 0. What's the sign of 0? Look at my arm again. 0. So 0 times 70 plus 150. So that is 150. So I could do that by plugging in 0 there, and I can actually do that without a calculator. So that ain't no thing. During the first 20 minutes, and this is in minutes, after the plane enters, at what time X is the plane exactly 100 miles away from the airport? This is the same. I'm not going to do it. You plug in 100 here, and you find those intersections. This would have to be a calculator because it doesn't turn into values on the unit circle. So it's the same exact thing I did in the last question. Is everyone okay? Can I end this movie? Is that it for those notes? So this is why we're doing 2 sets of notes today in 2026, because I just wanted a nicer free day tomorrow. So that's my decision. We're sticking with it.